let's imagine an empty hollow box, but one that is airtight. So it's I can put some gas inside. Not gas as in the gas that you use in your gas cooker or boiler for cooking, but gas as in like air or oxygen, nitrogen, hydrogen. All right, so suppose I put some gas in here. I'll just say oxygen. I'll put some oxygen inside. There will be lots of oxygen molecules. Okay, let's say I I just inject some pure oxygen. Right, so it's now here, oxygen. I want to think about the physical, the basic physical properties that can describe this gas, and by that I mean things like its temperature, its pressure, and its volume. And one more thing. There is also something else. Now that something else might be a bit tricky to describe, but let me start with mass. Okay. I'll use big M for that. Let me start with mass. Okay. We'll talk a bit more about this mass issue in a moment. So that's volume, that's pressure, and that's temperature. Okay. So in principle, actually in practice as well, all of these quantities can be measured. You might need maybe a slightly more complicated instrument for the pressure, but and for temperature you would need a thermometer. Mass, it's very light, so you might need some clever way to measure it accurately. But in any case, with some thinking, they can all be measured with the right instruments. So these quantities here, it describe this box of oxygen. Now, and in fact, if we just assume pure oxygen, in fact they describe this gas completely, all right, or this oxygen completely, if we specify all of this, in the sense that if I have another box, if you just imagine that I have another box of oxygen, okay, with the same I'll just say ditto, with the same temperature, pressure, volume, and mass. If I have another box of this, then if you look at these two, they would look exactly the same, right? There's no way you can tell between them, right? Not unless you can actually see how the molecules move and find that they move differently. But apart from that, they would just look exactly the same, like identical twins. Okay. So for this reason, we think of these four quantities as describing something about the state of this gas, right? We think about this as telling us about the states of the gas. Okay, and we think that as long as we know what these values are, or we specify these 4 values, we would have specified the state of the gas. Okay, so that if I just go ahead and make another box of oxygen and make sure that I measure the same 4 numbers for that other box, then I can be sure that my new box of oxygen would be no different from my older box. Okay, so it specifies the whole thing. All right. Having said that, there is now a relation between these quantities that I want to look at. Now, I'll start by writing down this relation. This is what it looks like. It is usually written as PV, P times V, pressure times volume, is equal to N times R times T. Okay, so I'm introducing 2 new quantities, N and R. I'll just briefly say what they are and explain more in a moment. Now, R is a fixed number. R is equal to 8.31. Let's see, I hope I get this right. Joules per mole. 5.81 joules per mole. And N is something which is called the number of moles. Number of moles. Coming back to here. Joules per mole per Kelvin, actually. Per Kelvin. So N is the number of moles. Now it is this idea of moles that I would need to explain in more detail afterwards. But for now, I'm just going to throw out the meaning directly, which could be a little bit strange if you're seeing this for the first time. Now, the meaning of the mole, 1 mole means 6.022 times 10 to the power of 23 particles. And by particles, I mean really any particles. So, but of course, for this particular example, it refers to the number of e.g. the number of oxygen molecules